Okay. Right, next we'll talk about bonding. Bonding in our atoms, because our elements don't exist as elements all the time. Elements can form compounds, all right? Let me hit that one first, all right? Bonding creates compounds. Compounds are not elements. Compounds are where there are two or more elements chemically joined together, all right? That's a compound. So let's do that. Two or more elements chemically bonded together. And there are two ways you need to know that our compounds do that. Okay? There are ionic compounds. Let's make that nice and stand out. And there are covalent compounds. Now, covalent and ionic are our two types of bonding, and I want to talk about the features of them. We'll try and almost draw them as they're being formed. Right, first and foremost, I need to bear that ionic compounds exist between metals and non-metals, whilst covalent bonds exist between non-metals. Okay? Let's give an example. Okay? Now I want to pick something that's a bit smaller so I don't have to draw huge. Okay. For example, lithium, which is the metal, and oxygen, which makes lithium oxide. That is a compound because I've bonded two elements together. Okay? Lithium oxide. And that has the symbol Li. Well, let me make sure that's balanced. Li is 1, O is going to be 2. Li2. Oh, I wish I'd never chosen that one. Anyway, alright. What does the 2 mean there, by the way? What? That's interesting. I really need to know that. What does this 2 mean? The 2 means there's 2 of whatever it comes after. Not the whole thing, but just what it comes after. So, Li, there's 2 of them. O, and it's almost like an invisible one. There's 1 of them. This doesn't exist, but what would that be? Li2O2. How many atoms in total?
4.
4. Good. How many Li's?
2.
How many O's?
2.
2. Wonderful. All right. I'm going to change this again for you. What about if I wrote this? What's the difference now?
2 of all of them.
Great. The big 2 in front means there's 2 of it all. So there's 2 Li's and 2 O's. There would still be 4 atoms there, but do you see how that is different to before? Okay. All right. So let me go back. So Li2O, right? Now in ionic bonding, they share. Sorry, what am I talking about? They lose or gain electrons. All right? Ionic bonding is all about losing or gaining electrons. And I'm going to try and draw it, give an example. I'm going to come over to here and then rub it out. Okay? So first of all, let us draw lithium. Right. Li, if we look at our periodic table, okay? If I come down here and I draw Li, I'm doing the mass number, the atomic number, okay? 7, 3. What does the 3 mean?
Protons and electrons.
Is it 3 protons or 3 electrons? Great. So, I would draw the nucleus, and for safety's sake, I'm just going to draw the nucleus as a central bit, because I don't need to draw it for my exam, but I know there's 3 protons in there. While I'm here, how many neutrons?
4.
Good lad, good lad. Anyway, I then have to draw the electrons, and the electronics configuration system tells you this. You can only have 2 in the first shell, and then it's full. There's no more space for the electrons. Then you have to make a second shell that can only contain 8 electrons, and you also have to make a third shell that can only take 8 electrons, and so on and so forth. Now, you will know it as 8, but it's slightly different, but just take that as red, okay? So, I'm going to rub that bit out. If this has 3 electrons, the X represents electrons, and I've filled up the first shell, and I've still another electron to place in the atom. So I add a second shell to my drawing, and I place the third electron there. This is the lithium atom. You all right with that so far? Mm-hmm. Okay. Now, I'm going to draw the oxygen. Okay? Now, if we look at the periodic table, oxygen is 8 and 16. How many electrons in oxygen? 8. So, I'll draw my nucleus. I'll draw my first shell. How many in the first shell? 2. Now, how many's left?
6.
6. Draw another shell. 1, 2, 3, 4. Now, I'm actually going to do this properly, because people don't do it properly. I want to get it right. When you're filling these up, you have to fill them up oppositely, right? So, 1, 2, 3, 4. Okay, so how many have I got so far? 1, 2, 3, 4, 5, 6. Am I done?
No.
No. How many more? 2. 1, 2. Okay, now, let me get into a crucial factor. The aim of becoming a compound is to have full outer shells. All these atoms want to have full outer shells. It's called stability. They want to be whole. All right? And so, you become a compound to have a full outer shell. This oxygen is 2 short. 2 electrons short, full outer shell. You could say this is 7 short. Or it's got 1 too many. Do you see that?
Just lose that one.
So, the lithium says, do you know what? And by the way, lithium doesn't talk, but, you know, you get me? The lithium says, I will lose that electron. I want to give it away. I want to give that electron away. And it does. And it gives it to somebody or an atom that wants it. Hey, I tell you what, you can have that. Now, we need to realise what this does. By taking that negative charge over there, we've now got inside here 3 positive protons. Would you agree with that?
Yeah.
But on the outside, we did have 3 negative electrons, but we lost 1. We've now only got 2 negatives. Would you agree?
Yeah.
So overall, have we got more positives or negatives? Positives. How many more positives? So we say this ion, and it becomes an ion when we lose an electron. This ion has a charge of +1. And we don't draw the 1, we just say it's there, it's a plus. So that is +1. Would you agree with that so far? But this isn't fully whole again. This isn't full, it's only got 7. It has to gain another electron, and it does that from another lithium. And I could draw that one down here, if you can handle that. There's the nucleus, there's the electrons in the base, there's the electron that it's about to lose. It gives it to the oxygen. The oxygen is now full. The lithium is now happy, but we've now got 2 positive ions, But if I look over here, hold on, how many protons have I got in the centre? 8. But now, how many electrons have I got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I now have 10 electrons. What's the charge of this? Negative. How negative? 2 minus. Do you see that? It's got 2 more electrons than protons. And because these are oppositely charged, they attract to form an ionic bond. Okay? Let's call that ionic bond with Luke covalent next. Good.